Hello, everyone.
Yeah.
Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken and Joel, Seth's brother. We're here to hopefully show you how to approach not only SAT questions, but also how to study for the SAT. A great
Uh-huh.
way to study for the SAT is to do the get yourself an account, get yourself an account with the SAT, which you need to in order to take the SAT, and then
Yeah.
start practicing the con questions. They
Yeah.
give you about 800 questions. There are about 40 topics on the SAT, and Khan gives you 20 questions per topic, and you just go through all the topics because this post 2016 SAT is really a test of stuff that you've done in school.
Yeah.
So this would be the 15th, no, the 16th question, right? 16, 17, 18, 19. Yeah, the 16th question in this series because we've done the first 15. See how we have all three things filled out? So we're at the top level. In order to get to the top level, you got to do the first 15. But we're not doing the first 15 because we think they're too straightforward. You can do those yourself. Okay, here we go. So please do the question, pause, come back, and we will do it. So basically, we have operations with polynomials. That's the topic for today. It seems like the best way to do this is just to deal with the two terms that you have to make sure are right. Does that make sense? To check.
I'd say, yeah, well, more precisely,
the constant term
instead of multiplying, instead of working out the whole expression, you compare the terms one at a time.
Yeah.
And skip the calculations of terms where there's no difference.
Yeah.
Among the answers.
So, well, look at this. Look at this, Seth. Look, there's a minus sign here and a plus sign on the constant term. So that means that the constant term has to be negative in the answer.
Yeah. Which
means that we could cross these out because these have constant terms of positive sign. Let's see if just doing multiplication of plus and minus signs will work. This is a positive s times a negative 7s. So the s squared. Oh.
Okay. No, better yet.
Yeah.
Using the sign of the constant term.
Yeah.
You could eliminate these two.
I just said that.
Hold on. And then you look at these two, and the only difference is in the linear term.
Right.
So then you pick out the linear term from here and see which one it is.
Oh, right. Yeah. That's a good idea.
See, it's easier to see
that
these are equal and these are equal.
Right. Yeah.
Right?
Yeah. I was going to go ahead and do the...
well, you were going to waste time.
Negative 7s.
Yeah.
Wait a second, though.
And in fact, the way they pose the question, the square terms and all distractors are the same. But that doesn't matter. It's a waste of time to worry about that because you've already eliminated C and D.
So am I going crazy, Seth?
I know.
Wait. Hold on. This is a positive s, and this is a negative 7s. When you multiply this, you get negative 7s squared, don't you? Are we missing something?
Well,
are we missing something? Look, there's the s times
negative 7. We're worried about the square term. So there are we're looking at the linear term. The linear term is minus 7s times minus 2 gives you minus 14s. But there's another linear term. There's s times 4/3. Right? We have a 14 plus a 4/3, and that's negative because 14 is very big. And then the whole, remember, also have to notice that each of these answers has a common factor of a third out there.
Right. Yeah, yeah.
Oh, so the you have to do is take 14 times 3 minus that plus 4. The whole thing is divided by 3. So, wow, that's 14 times 3 is 1242 plus 4 is minus 42 plus 4, which is 38.
Right. So you didn't get it?
Well, so something's inconsistent there.
Well, first of all, let me go back and tell people where the mistake I was. I just did the s times the negative 7 to get negative 7s squared. And I said, hey, there's no negative 7s squared. But I realized there's an other s squared term, which is negative 2 times negative 2 times 7/3 s squared,
Yeah.
which is negative 14 cubed s squared.
Yeah.
Wait a second, though. Wait,
Something
am I
wrong.
going nuts here? Then this s squared term's got to be
Okay.
negative.
I don't know. I think we're worrying about whether the question itself is faulty. And none of the, so let's systematically simplify the top and see what we get very carefully.
Before we do that, can I double check your work first?
Yeah.
Okay, so Seth's just looking at the linear term. So what is the linear term? It's s times 4/3, so it's 4/3 s. Okay, and then negative 2 times this, which is
positive
14s plus 14s, right?
Yeah.
Right? Okay, great. So now let's do these. This is 14 and 1 1/3. So this is 15 1/3 s. So
Yeah.
I'm pulling out a third, so this would have to be a 15s, positive 15s. Well, there is no positive 15s here.
Well, we're pulling out a third for it. 15.
Hey, no, what am I doing?
15
I'm
and a third
wrong.
s.
Oh my god, am I stupid? Oh my god.
45 is 46 thirds.
46 thirds. I am so.
Yeah.
That is really bad of me. All right, 46 thirds. Yeah, so then the answer would be positive 46. What's going on?
It's possible. We really should look at this carefully because it looks to me now that none of the responses are equal to the given.
Okay, so why don't we clear all? Okay.
Yeah.
And we
so
start
let's
from scratch. Go ahead. Clear all. Let's.
It's
something very strange.
Very unusual.
Yeah.
For what we are worried about is the case here for the SAT question to be poorly posed, but we are saying is we are making this video to show you how to do it quickly. But now we are concerned that our attempt to do it quickly gives us less certainty,
right,
in our own minds about whether our calculations are correct.
So we have to.
So what we're going to do is redo the calculations much more carefully and slowly.
Right. So no, we're gonna do it like we're gonna. Wait a second.
Let's one at a time calculate the s cubed term, the s squared term,
Seth,
the linear term, and the 4 terms, 4 calculations, and what do we get?
Stop. We made a huge mistake. It's our fault. We made this a multiplication sign.
Not me.
Oh, well, I did. I did.
Wait, did I? I think I did too.
Oh, my God.
That was dumb.
Oh, my God. Okay, well, let's play it again without making it a multiplication sign. Okay. That is unbelievable. This embarrassing.
Oh yeah, we both did that. Yeah, I think. Yeah.
Goodness. Okay. I'm surprised. You know what I'm surprised at? is they didn't have that as one of the answers. Do you know what that means? That means that in their wildest imagination, they couldn't have anyone being that stupid as we just were. Can you imagine that? That's great. Okay, well, no, that's in other words, we didn't get the answer, so now we got to go back to the videotape. Oh my God! So let's just do it again,
So
right?
we could do it the same. We could do the same procedure.
Yeah, except this time we'll try to do it right. So the constant term is -2 plus 4/3. So that's less than 0, right? -2 plus 1 1/3 is less than 0. So we throw these out.
Yeah.
Right.
Well, you threw them out because of the pluses.
Because -2
because
plus
of the 2,
4/3 is less than 0.
Okay.
Right? Okay. Now,
same reason, from among the ones that are left over, the only difference is in the linear term.
Right. Yeah.
So we look at the linear term of this. It's 1 times s.
And there's a -7.
We look at the linear term of this.
Yeah.
And it is nothing. There's only one mult. There's no. This thing in parentheses has no factor. So the rest of the linear term is -7 times s, and that equals -6 times s, which
is b. It's b. It's
right?
B. It's b. Yeah. Yeah.
So it's 1 times s plus -7 times s is -6 times x.
Yeah.
However, the top thing here is a third of it, and -6 is 1/3 of -18.
Oh shoot! Oh, so I got it wrong. This is not a good day. It's Monday. We shouldn't be doing math on Mondays. I fell into a trap. Oh, they are so man. Oh, wow. I mean, it was a coincidence. A was marked before. Trust me. Just happened to be clicked the wrong place. Just clicked around. Oh no. Oh, so Seth, I went too fast.
Yeah.
Oh, that is really embarrassing. Wow.
Yeah.
Yeah. Oh God. What do we do other than math is humiliating?
Well, we figure we that's the one.
Yeah.
Hey.
Yeah. Wow. Yeah. The answer is -6.
So a tricky thing is what's there's what you have to watch out when your habits of seeing old problems lead you to overlook a difference from the routine.
Yeah, well, it's human nature, right? It's human nature when you look at a problem to look at it under the lens of problems that you're used to, or problems that you think it is, right? Without actually looking and reading the grammar. We do it with sentences also. I mean, you're a human mistake.
Well, mathematics teaches you to to get by in life, to get by with habits that prevent these dumb mistakes.
Yeah, but no matter
dumb mistakes that are due to human nature.
What's really frustrating is that it looks like no matter how hard you try, to your last dying day, you still make them sometimes.
Well, that's to your last dying day, you're still making mistakes.
Right.
And then when you want to avoid the mistakes, you have to check, recheck, and keep. It's a never ending enterprise.
Never-ending enterprise, yeah.
Okay.
Yeah. Okay, so anyway, I guess we have to move on. So let's make sure that this is right, which I'm sure it is.
No, let's compare it to the answer they gave.
Yeah. They probably said. So as good as was question 16, it is a little more challenging.
Yeah.
Let's see. What do I do here? Check. Oh no, I don't want to do that. I want to answer it.
Okay.
I want to answer it. Okay.
Yeah.
Yes, fireworks. Congratulations. We got it finally right. When adding, we look for like terms, which power of s occurs in both left and right polynomials. S occurs in the left polynomial with negative s on the right, so we add the two together. They do the s term.
Yeah.
Then they do the well, they're doing okay. Wow, they're really going through brute force, right?
Yeah. Use all four.
Wait. Oh, I see. Then they keep going. Let's factor out the 1/3 to yield the answer. Yeah, so they're basically doing it. They're not taking shortcuts. Yeah. So yeah, when you take shortcuts, you got to be careful. They're doing a little bit less shortcutty.
Yeah.
But it would take longer. So,
Yeah.
yeah, when you first do these problems, you probably should not take the shortcuts. But it's so tempting because you're in a rush. You really sort of have to take the shortcuts on the SAT. You have to try to at least take the shortcuts, but you got to really be careful. So, I don't know what else to say. It was just an embarrassing day for both of us. Okay, 2 demerits for me, 1 demerit for you. So, okay, guess we better go before we make any more mistakes today. And next time we do these questions, we will be more careful. Just like you, when you make mistakes this stupid, you should also be more careful on the next time so that you remember, oh my God, I got burned on that one. And again, nothing counts until you actually take the actual SAT. Okay? It's all spring training until you actually take the real test.
Yeah.
Okay. Anything else?
Oh, I think yeah, no.
Yeah, I mean, you can see the whole answer there.
Yeah.
They do the whole thing like that. Yeah. They're not quite following exactly what they do. They're doing it a little bit, I don't know. It's hard to, I guess you have to write it all out to follow what they're doing.
Yeah.
But it's not really necessary to
Yeah.
Yeah. Okay, everyone. Have a great day, and we'll hope to see you tomorrow. And please like us, dislike us, and give us comments on our YouTube videos, except I can imagine the comments you're going to leave today. And if you have any SAT math questions, please email us at satmathquestionoftheday@gmail.com. And everyone, have a great day. Take care.
Bye-bye. Bye-bye.
Okay, I need to stop
The result of